A randomly selected group of individuals were asked how many marbles they believed were contained in a sealed jar. The following frequency distribution summarizes the results. Complete the table by determining the midpoints, relative frequencies, and cumulative frequencies. Let's begin with the midpoints. The midpoints are the middle value of the class range. And you can generally estimate these. Like the middle value of 80 and 87 is probably something like 84, 85, somewhere in that range. So when you get your answer, make sure it matches up with what you think it might be. There is a formula for a midpoint, and the formula for a midpoint is to take the lower class limit of a class plus the upper class limit of that same class and divide by 2. So effectively what you're doing is you're averaging the lower and upper class limits of a particular class. So for instance, in the first class, if I take 80 plus 87 and divide by 2, that gives me 83.5. So my estimate was pretty close. I said 84 or 85. I was a little bit high, but it is right in line with my expectation. So 83.5 is the midpoint of my first class. Now I can do the same for the next class. 88 plus 95, divide by 2, and that's 91.5. And what I can do is just continue this process for the rest of them, and that's fine. But if you'll notice, if you take the difference between any two consecutive lower class limits or any two consecutive upper class limits, that can give you your class width. So the class width of this table is 8. Now if I take 91.5 minus 83.5, that's also 8. So what you can actually do to speed things up here is get the first midpoint and successively add 8 to that value and get the rest of them. So 91.5 plus 8 is 99.5, plus 8 more is 107.5, and 8 more than that is 115.5. Now, relative frequencies. There's also a formula for relative frequencies, and that formula is, write that a little bit better, to take the individual class frequency divided by the total number of data items. Essentially, this is just finding a percentage. So if you think of it more in terms of finding a percentage, then it's not really a formula that you have to memorize. It's just a process that you already know how to do, and you're applying that process in a different manner. So the individual class frequency for the first class is 9. And I need to divide that by the number of data items that appear in my data set. The number of data items that appear in the data set is the sum of my frequencies. So let's take a look there. Let me grab the calculator so I don't make an arithmetic error. 9 plus 7 plus 5 plus 6 plus 3. So that's a total of 30 data items. Now, if I take 9 divided by 30, that's going to give me my first relative frequency. So 9 over 30, that is 0.3. And then if I take the next class frequency divided by the total, which is still 30, it's 0.233. And that's my next relative frequency. Then 5 divided by 30, oops, missed my divide. That is 0.167. Then 6 divided by 30 is 0.2. And 3 divided by 30, should be, I still messed that up, didn't I? 3 divided by 30, it should be 0.1. Okay, good. All right, so great, got it. Now, one thing that's interesting about relative frequency is that the sum of your relative frequencies, so if I were to add all of these relative frequencies together, it's either going to be exactly 1, which is what it should be in theory, or it's going to be something extremely close to 1 due to rounding errors. So let's see what happens in this set. If I add up my relative frequencies, it comes out to exactly 1. And you can use that as a check. So if you know that fact, then you can take your relative frequencies that you found, add them together, see if they're equal to 1. If they're not, then you've done something incorrect. Now, the cumulative frequencies. There isn't really a formula for cumulative frequencies. There's really just a process that tells you to take a running total of individual class frequencies. So for instance, we start this process. The first cumulative frequency is always just equal to the first class frequency. The next cumulative frequency, we allow the frequencies to accumulate. That's where this is getting its name from. So if we take 9 plus the next class frequency of 7, then 9 plus 7 gives me 16. So that's the next cumulative frequency. And I keep doing this process. So then 16 plus 5 is 21. Then 21 plus the next frequency of 6 is 27. And then 27 plus 3 is the final cumulative frequency, which is 30. And that's how we do a cumulative frequency. So just understand the process. And again, there's no real need for formulas here. You just know how to go about the ideas here. And a good check there is your last cumulative frequency should always equal the total of your frequencies. So if you've done both of them correct, then you should get the same result there.